So as a recap of where we are, quiz due tonight, last quiz grade. Remember, it drops the lowest, so tomorrow morning when I get to school, I'll put those grades in and, knock on wood, of course, if there's no other issue, but that's when I plan to do it, and I'll drop your lowest quiz grade. You have your last homework check this Friday, last homework check, last test next Tuesday and Wednesday. So we have new material today and tomorrow. That's it. This is our last section, 2 days of this. Then we have 3 days of test review, Thursday, Friday, Monday, test Tuesday, Wednesday. Okay, so that will finish off the first half of the course, right? What you'll probably feel about today is like, oh, I feel like I've learned that before. This is very much a review of stuff that you were taught in Algebra 2, which is properties of logs. And so let me do a few examples with you. Like I said, the notes are not very long. You'll have a lot of time to work on your homework. Asking for help, working together, of course, is always okay, as long as we're working, right? So let's get started. With logs, there are 3 properties that we have to be familiar with. And what we'll do with these is apply them to some problems. And there's basically 2 types of problems that can come from these, where we're given the left-hand side of the equal sign, and we have to write it like the right side, or vice versa. So the left hand of all of these equal signs is called a single log or condensed log. Single meaning just one, and the word log is only written one time. On the other side of the equal sign is what we call an expanded log, and that is more spread out, okay? And so what we're going to do is apply these properties and do these types of problems. You might notice that there's 2 columns here, log base b, natural log. They're the same exact thing. I'm not even going to talk about this. Remember, natural logs are logs, same exact stuff. The properties that apply to log base b apply to natural log base e, okay? So first one is the product property. Product means multiplication, right? Product is multiplication. You're going to think addition anytime you see multiplication. So what we have here is log base b of m times n. That's product. When we expand it, each of the 2 terms, in this case there's 2, m and n, each of those 2 terms get the log and the base. Don't leave anybody out. It's rude. Give everybody a log base b, and then you just expand it by changing multiplication to addition. There's another time in your life, your math life, that you put these 2 operations together, and that's with exponents, x to the second times x to the third. When you're multiplying with like bases, you add the exponents, so maybe that will remind you, okay? The quotient property means division, and you'll think of subtraction. So again, I have log base b of m divided by n. Think of it as a fraction. Fractions are division, okay? M divided by n, m over n, expands to m minus n. Log base b of m minus log base b of n. Okay, think of that little fraction bar as a subtraction sign. Looks like a subtraction sign to help you remember. We also had problems where you would have like x to the 5th over x to the 3rd, and whenever you divide exponentials with like bases, we would subtract the exponent. So we've had another time in our math life where division and subtraction went together. So those should be pretty familiar. The power property is simply saying if you have log base b of n to the power of p. So b, n, and p can be any number, any letter. That's the whole point of this, okay? It can be anything. You can rewrite that exponent of p as a leading coefficient. So if you notice, once we get to the other side of the equal sign, that exponent goes and stands right in front of the log. And you can go back and forth, okay? So an exponent can become a leading coefficient. A leading coefficient can be written as an exponent. All right? Before we get to the examples, I want to remind you of some things you are going to see all the time. And kind of got myself in a bad mood last period because nobody seemed to remember a lot of these. So please just participate if you know. Maybe they're just quiet. I don't know. But there's some things that I've taught you so far that are reoccurring that are going to occur again today. What does this simplify to? What's log base b of b equal? 1. Right. Remember, no matter what the b's are, they can be numbers, letters, doesn't matter. If they are the same, it simplifies down to 1. Okay? How about log base b of b to the x? What would that simplify to? Well, guys, what's log base b of b equal? 1. And that x is all that you have left. The answer is x. But think of it now that I've introduced the power property to you. You could write that x in front, right? That's this. You could write it in the front. And so you would have x times 1, which is just x. All right? How about this? What does log 10 equal? 1. Why? Why, Remy? Why is that just 1? Right. The base of that's a common log. Remember, when you see LOG with no subscript number, that's automatically a 10. So this is this. That's your log base b of b. It simplifies down to 1. Okay? How about this one? It's what? What is the base of a natural log? E. When you see, okay, let's review this. These two are super important. And maybe I'm not doing my job because last period was not remembering this either. And I feel like I've talked about it a lot, but it seems like it's not getting in. So let's make sure we understand this. Again, if we see LOG, log, with any number, okay, but with no little subscript, that's a base 10, okay? So anything, log of x is the same as log base 10 of x. Log of 107 is log base 10 of 107. Doesn't matter what's there. If you don't see a number here, we know it's 10, okay? Natural log, you'll never, ever, 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 ever see a base, okay? It'll always have just ln and a number or letter. There'll never be something there. We know, though, now, I hope, that it's always an e, okay? Always. So if you see natural log of x, you could rewrite it if you wanted to as natural log e of x, okay? So natural log of e is natural log base e of e. Even though it's not written there, we know it's there. So whenever you have the same numbers or letters here, it always simplifies to 1, right? We got that? It's super important. You see it all the time, okay? So that equals 1. Switching gears a little bit here. Don't forget how to rewrite radicals as fraction exponents. So that would be x to the 2/3. Okay? A common one we see is just like that. That x has a 1 on it, right? And what number is in the little hook here? 2. We don't write it, we know it. So that would be x to the 1/2. You're going to have some of those. And lastly is, if you have a number that starts with a 1 and has any number of zeros after it, for example, 10,000, okay? You can rewrite that as 10 to the power of however many zeros there are, okay? So 10,000 would be 10 to the 4th. 1,000 is 10 to the 3rd. And you get the idea, okay? Because those are kind of common in what we're about to do as well. All right? So these kinds of things are just those little bits of knowledge that we have to have that just kind of get sprinkled into all of the stuff we do with logs, all right? And you're going to see a lot of this as we go through. All right, so first example is given a single log, expand it, okay? So what I see is all multiplication, 8 times x times y to the 4th. There are 3 terms there. I am going to write the word log 3 times, okay? So I'm going to start with that. Log 8, and multiplication and addition go together. So it's log 8 plus log x plus log y to the 4th, okay? Now, half the battle, 95% of the battle with these problems is not what we just did. It's knowing, did I simplify it enough? Is there anything else I can do, okay? So first thing is this. So listen. Anytime the number right here can be rewritten as an exponential, you want to do that. So, for example, if this said log 7, there's nothing I can do with it. Log 10, nothing I can do with it. But 8 can be rewritten as 2 to the third, right? 9 could be rewritten as 3 squared. 4 can be written as 2 squared. You get the idea. If that number can be rewritten as a radical, as an exponent, you want to do that. So that would be log of 2 to the third. We didn't break any rules. 8 is 2 to the third, okay? And our very final answer would be anybody that has a power, the power goes to the front. That's applying the power property. So we have n to the p, the 3 goes to the front, the 4 goes to the front. So my final answer would just be this. Okay. All right, let's look at another one. I'm just going to skew over here a little bit. Okay, so I have division, and I have a radical. Let's just take it one step at a time. Natural log of the square root of x squared plus 5. Division, subtraction. Everybody gets the ln. Okay, so a very common mistake is to write exactly what I wrote here, but leave the ln off on the second one. Okay, remember, when you expand, every term gets the log. Okay, there's nothing you can do with ln x, right? That's just natural log base e of x. There's nothing you can do with that, all right? But this one is this situation. We're going to rewrite that as a fraction exponent and then bring it to the front. So x squared plus 5, that's all. They don't have a power around them. It's just x squared plus 5. There's one of them in there. So this is just like this. It's 1/2. That's natural log, in parentheses, x squared plus 5 to the 1/2. And then now that it's an exponent, we bring it to the front. What? It was there. It looks much more complicated. Like, am I going to have to square root something? None of it, okay? It's just whatever's in there, just take it and move it together. It just goes with it. And that's the answer. Okay? You know, these take practice. And like I said, the good news is you're going to have a lot of time in class to work with me helping. So if you're like kind of unsure about stuff, I did show all the steps in the key. But of course, I'm here to help you. Okay, so never, ever feel like you're bothering me. I like to help you with that. Okay, now let's go the other way. These are already expanded. We're going to condense them or make them into a single log. So I'm going to write ln just one time. And remember, ln and log mean the same thing. It does not matter at all. All the rules apply. All right, so I have x to the 5th divided by xy. That number in front is now going to become an exponent on the xy. Notice I dropped the second ln because we're going to a single log. I only have to write ln one time. Now, I can simplify that. On the bottom, I have x squared y squared. That parentheses is like a distributive property, kind of. Like everybody in the parentheses gets that power. I didn't mean to make such a big space there. And then finally, we can simplify x to the 5th over x to the 2nd. Remember, that's just subtraction again. Division and subtraction go together. So I would have x to the 3rd over y to the 2nd. 5 minus 2 is 3. And that would be your final answer. Okay, last one of these. I see addition, so I know there's going to be multiplication involved. I see numbers in front of my logs. I know those are going to become powers. What I like about this problem is something I want you to notice. The ln x to the 3rd y doesn't have parentheses around the x to the 3rd y, and this ln does have parentheses around it. That's because it could be written either way, and either way is correct. Okay, so it's not a typo or anything. I think the reason she made it look like this is for that reason itself. This is natural log x to the third y. Even though there's no parentheses, and there could be, it wouldn't be wrong to put parentheses, of course, it infers that all of this belongs to that log. So when I apply the 3 to the power, I would need to make sure I put parentheses because I want to say that the 3 goes to all of that. If I didn't put the parentheses, I would just be giving the 3 to the y, and it should go to all of it. This one's a little bit clearer because the parentheses are already there. So changing addition to times, dropping our second natural log, this would be y z squared to the second. Right? So I just gave each of the log's numbers in parentheses the power out in front. Okay? Now we can simplify this, guys. We can distribute that 3 to everybody in parentheses, distribute this 2 to everybody in parentheses. If there's already a power there, you multiply. Okay? So that would be natural log x to the 9th, y to the 3rd. Again, you could put parentheses around this or not. It's not necessary, but if you do, it's not wrong. Okay? And then over here, y to the 2nd times 2 times 2 here, z to the 4th. And now let's just make it into one happy log. Let's go alphabetical order. X to the 9th has no other friends here, so it's just x to the 9th. Y to the 3rd times y to the 2nd. We would add those exponents. And then z to the 4th. And again, you can leave it just like that. You could put parentheses around all that stuff. Either way, it's the same answer. Both accepted and fine. Okay? Does it kind of come back to you from your past? Okay, and you too, Sam. You better say yes. And Riley and Raja. I forgot. I have so many students in here that were in my Algebra 2 class. Thank you. Okay. Super important, easy, lovely formula to teach you. This complicates things so much. There's something called a change of base formula. You'll see me abbreviate like this. Let me just sum it up for you, and I'll explain what it means. If you have a log base b of m, b and m can be any number, any letter, doesn't matter, okay? And you can rewrite it changing the base b to a base 10. Remember, base 10s are our favorite because there's that easier button on our calculator. I'll come back to why this is important. And how we do that is we make a fraction and we divide. Notice log m is on top, log b is on the bottom. We went from a base b to dividing two base 10s. See how there's no number there? Those are base 10. How can you remember which one goes where? Really simple. The base, which is always lower than the m, b is always lower than m when you write it, that goes to the bottom. It's lower, goes to the lower half of a fraction. So let me show you why this is important, okay? If I applied the change of base formula to this, what I would have is log of 13 over log of 3. So on your calculators, I showed you already a way of putting that in. Like, technically, you students don't need the change of base formula, okay? You all have a way of going in your calculator and going math, alpha, math, putting a 3 there, putting a 13 there, right? And hitting enter and getting your answer. Why is this important? Well, there's a question on your test about it. And if you were working with a scientific calculator, or let's pretend you're on the AP test and you can't find the log, you don't remember how to find that button. Knowing this formula means you can just use the log button. Scientific calculators, the ones you've used in all your other math classes, have a log button on them, which is log base 10. So you could do a problem like this with a regular calculator by knowing this formula. So just one thing to think about when you type it in your calculator, it's log 13 If I just keep typing divided by log 3, I'm going to get the wrong answer. Because see how it's in parentheses? What you'll see me do is put, when I write it, just to remind you that you want to close your parentheses before you divide by log 3. But you'll see you get the same answer. And one more thing, you could also use natural log 13, close my parentheses, divided by natural log 3, and get the same answer. So you might see it written as log here and natural logs here. It doesn't matter. You can do either one, as long as you pick one and stick with it. And then we just round correctly. So this one would be log 10 over log 6. This one would be log 2 over log 0.5. This one you get -1. This one you would get, and we can just skip through these. I know you guys know how to type buttons in your calculator and round. You'd have a couple of those in your homework, so you can practice that. But just don't forget the parentheses and then divide because of the way the calculator is. Okay, so change of base. Freebies, really. Last question. This is pretty cool. Given g of x is this, we're going to transform that by using the product property to show that this g of x is actually the parent function of log base 2 of x vertically translated. Really, really simple. But it's kind of a cool idea. Because if we didn't do that, if I said, go ahead and graph this without a calculator, you would say, oh gosh, what does that number in the parentheses mean? We didn't even cover it in our notes, if you remember. That's a horizontal dilation by factor, flip it, of 1/4. That's multiplying all the x values by 1/4. It's a pain. But watch what we can do instead. We can take g of x, which is log base 2 of 4x, and rewrite it as an expanded log, just like we did in that very first example. That's multiplication. So that's going to be log base 2 of 4, multiplication plus, give everybody a log. It's rude if you don't, right? That's expanding it, 4 times x. Simplify it. If this number can be rewritten as an exponential, then you would do that, right? 4 is 2 squared. Right? And final answer, y'all, what does this simplify to? 2. 2, right? Log base 2 of 2 is 1. That 2 goes down front. It's just 2. Not log 2, just 2. Log base 2 of 2, log base 2 of 2 is 1, right? Log base 2 of 2 is 1. And then that, all we had left was that exponent of 2. So what we just did was using all the correct laws of math, our properties, and we transformed a horizontal dilation by factor of 1/4 to a really simple graph of a parent function and then move all the points up to a vertical translation. So graphing both of those, really simple. Tomorrow we'll do more of these. Today, don't even worry about putting it in your calculator. What we learned yesterday, or talked about yesterday, is in a parent function, which is what this is. It doesn't matter what the base is. You're always going to have an x-intercept of 1, 0. You have an asymptote here. Just draw the general shape. Okay? That's the parent function, log base 2 of x. G of x is taking all those points and going up 2. So we really just have this point. Move it up 2. Easy sketch of it. There's my G of x. So using our product property, it was a really easy way of being able to graph something. Whereas anytime you have a dilation, if you're doing it by hand, it's a lot of work. You have to multiply x's or y's by a value, okay? So it's a lot more work than that. Okay, last thing, let's just describe the change in the output to inputs. So in this graph, as x values increase by a constant value. I'll let you catch up while I tell you what I mean by that. When we were looking at table of values, we had to make sure the x values were either adding 1 or going by 2s or 5s. It couldn't be like 1, 7, -8, right? It had to be constant. we don't, you know, a lot of times they'll say by or adding 1 or adding 2. I don't have my XY chart, but I know that this is an exponential function, and by definition, an exponential function has the x values increasing by the same amount each time. As the x values increase by a constant rate, the y values are translated or shifted up to, that's what we did, right? We went up 2 because of this plus 2. Remember, that's the k value because it's separated by a plus sign. That's your up 2, right? So we're going to do, this is our final thing we have to do tomorrow, is just a bunch of these. Just today I gave you one of them in the homework. Okay? So I'm going to put the homework assignment up, and then I'll put the key up. If you want to work on your quiz after you write the assignment down, that's fine. Get it done. Let's not have zeros on quizzes, which means you'll have to make up this homework. So make a decision about what you want to do in class, but do something. Mm-hmm. We should be writing the assignment down so I can put the key up, guys. And now?